Recording in progress.
Hello. 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 Yeah, fine, I think.
Can you please share your screen? I will check.
Oh. Screen is shared. Hello. Okay. Hello. 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 Yes. It's okay, right? So it can be hidden, right? Okay. So right now, everything looks fine. Okay. Anyway, very good morning to every one of you. So my name is Vishwa. I'm in Bentley as a senior structural engineer and working in Bentley for last 17 years or so. And before that, I was in different consultancy firm. Now, mostly I'm associated with structural products like STAT and BRAM. I got this opportunity to visit Indonesia second time. First time maybe in July or August this year. I visited for a conference, and this is the second time. So it's great. It's my pleasure to interact with you. And our agenda is just to give you a quick workflow and introduction to latest enhancement, latest technology, which can give your work very well and smarter experience. And our technology, our products are evolving to give you a better integration with other products. So before I take you forward, just I want to know from you, like from maybe you can start your introduction from this part. like what are the type of structures, what are the industry you are from, and what is your level of experience in STAD or maybe similar products from Bentley? Yes, from you. Yes.
Samja.
Okay.
I'm from electrical engineering.
Okay.
I just start for construction.
For structure, right? So what type of structure? Concrete, it's industrial construction, offshore, concrete, right? Okay.
Yes.
Okay, it's for building or other type of structure like industrial structure?
Shelter or foundation.
Shelter or foundation. And are you using STAD or any other battery products? First time. Okay, which products? Or you are using your Excel spreadsheet? Or SAP?
Yeah.
Okay. Anyway, thank you. You, madam?
I'm from the environment as well as
Yeah.
just learn new.
Pardon me? Okay. So you're also from offshore, right? You mentioned?
Onshore.
Onshore. Okay. And you're also in concrete and steel. None of you are from steel?
Still.
Steel, okay.
Still.
And you, sir?
My name is Irwan
Okay.
from Desa.
Okay. So what type of product or structure project you are handling?
Some
Okay. And type of structure? Building, steel, concrete.
still background.
Okay. Steel or concrete you are doing the project? You're in the project you are handling steel or concrete?
Oh, still
Steel. Okay.
concrete.
Both.
Yeah.
Okay. Okay. And you are using STAT for the first time or you had some previous experience on STAT too? Okay. Okay. I understand so that I can accordingly communicate with you. Yes, sir.
I'm Bagus from two company.
Okay.
In media, and one is Multimitra. Multimitra is
Yeah. I know that.
That's right.
Okay. Oh,
That's right.
okay. Good.
That was friend.
Multimeter we have been working with, yeah. So you are also in the structure?
Yeah.
Okay.
Usually, yeah, in we have a consultant
Okay.
for building and infrastructure.
Okay. And type of structure you use? Steel, concrete, both?
Usually it's concrete.
Concrete.
Yeah.
Okay. Okay. And do you have any previous experience on STAT Pro?
Yeah, but already long time.
Long time. Okay, no problem. So I have heard all of you because see, whenever I will be discussing, I want to know like what is your level of experience on STAT. I know that every one of you are working on your different projects so that I can start accordingly. If I jump onto some certain, feature, that it will be, very confusing for you. Anyway, let's start with just to give you some quick introduction with some quick success story of some challenging projects that our client has done with our STAT. Then we will take you through our live demonstration. So this is one of the award-winning success story from Bentley user. That is the bungee jumping in Rishikesh is in India. It's a northern part of India. It's in the Himalayan terrain. It's a very rugged terrain and it's a highly seismic prone zone. So building, not building exactly, it's a kind of tall, steel structure, which is supposed to stand on that foothill and a lot of recreational activities would be performed. People will go all the way into here from this cable rope and they will plunge for the bungee jumping. Now, this project is a very challenging one, considering the fact that there are a lot of harsh climatic actions. For example, it is supposed to withstand, first of all, it's a highly seismic prone zone. because it's a fault line in the Himalayan belt. Secondly, it is susceptible to experience extreme wind load around 180 kilometer per hour. Also, during the monsoon, it experiences a lot of natural calamities like flood, landslide, and so on. And that's the reason a lot of care has to be taken into consideration while performing the construction. And you can also see that it's not a flat surface that we can manage to go with a lot of soil stabilization and all. Whatever is the existing, profile and existing options we have to utilize that. So our consultant, their name is, I think, Skeleton Consultant from India. So they have undertaken the projects with STAD, and a lot of challenges they have to face. First of all, you can see this is a standing structure, and on top of that, from this area, bungee would be posted. There would be a kind of cart by which the passenger would move from the top to bottom, and then he will plunge down just for the recreation. Now, for this one, they have to manage this with some ropeway system here. And on top of that, as being a very tall structure, it has to be made very much stable. So this is their model. They have used StatPro for modeling the steel, and on the ground, they have used those concrete pedestal. And the entire system is hoisted by, you can see some thin lines. These are the pre-tension cable. These are not the normal cable that we consider like just like, member, which is being assigned with some tension only. It's not like this. These are the dedicated cable element, which we can also perform the advanced cable analysis because they will also just form the catenary profile. So we have to perform a lot of different advanced analysis along with some geometrical as well as material optimization while we do the steel design. So they have shared their success story after they could save several man hours and the quantity of steel. So we have performed nonlinear analysis there, nonlinear cable analysis to stabilize the structure. And eventually we instead do have the option to optimize the steel design. We'll show you in the next model. This is another similar kind of success story we had. And this is much more larger in the sense this is based in the same location. You can see at the foothill of Himalayas. And these are very rugged terrain. Occasionally, we do have the roadways at that elevation, but government has now started to construct the railways. So constructing the railways at Himalaya is a very challenging task. The reason being you don't have those easy slopes. We have the steep slopes, and you can't even disturb those soil profile because these are very geologically sensitive area. Little bit of disturbance, then you will see the landslide and everything would coming down. So a lot of research and a lot of testing and studies were done initially, and carefully those things are sorted out like which would be the best profile. And as it's a railway track, we can't go like this. We have to maintain some linearity. So if there is any gorges or riverines, we have to pull in some bridges. And if there is a hill like this, we can't turn 90-degree, right? We have to go pass through that mountain. So that's a challenge we had. Not only STAD was there, we had several other products like Plaxis we had for soil structure interaction. We had Open Bridge Designer, Open Rail Designer. So a lot of Bentley products were used, and STAD played a very important role there because for the structural modeling and design. This is one of the snapshot you can see. The rail is the rail bridge, and it is just coming out of the river and going inside the mountain. So that's the biggest challenge we have. And the consultant is WSP. You might be aware of the name. WSP previous name was Louis Barger. It's a big company, and they have undertaken this project. And for the bridges and all, they have used StatPro. Now, instead, we do have different options to model different trust system, and we can use some option called optioneering, by which you can use our cloud server to create different sample models and ask the cloud to just perform all the analysis simultaneously so that you can assess the most optimum one. So different scenarios can be performed, and you would be given with the different parameters by which you can evaluate that which would be most optimum. Optimum could be like strength, it could be amount of steel used, it could be volume of steel used, a lot of other things. So you have to define the criteria and the constraint, like, okay, I can allow this much of displacement, I can allow this much of utilization ratio, that's all. So yes, with this optioneering option by the cloud server, they could find the most optimum, design profile of this entire span of this bridge. This is one of the example. There are several other examples they have cited for their entire project, and they came up with some best suited bridge solution, which they have taken by StatPro. So in some cases, they have shown us the cross-section area where there could be like steel deck on those truss system, and they model with the plate elements, member elements, and instead we have different options to assign different releases, member and releases. So they could successfully achieve this target by modeling carefully in StatPro. This is their, after their design, they have shared us the cross-sectional drawing profiles. So yes, as we have mentioned, like in Bentley, we are no longer only focused on stat. We have so many other solutions. We give you the total solutions. Say, for example, right from the data collection, you might have seen that I have shown you first of all the plan. We have a product called Open Site Designer, then Context Capture. These are used to collect the site data from the drone and all, and these are fed in the system to give you some topographical information. From there, there are products like OpenBridge, OpenRail. These are used to find the geometrical alignment. And then you have got all the structural requirements, structural components. So there's a workflow, and this entire workflow were used by different collection of Bentley products. And here STAT played a very important role. So StatPro structural modeling was done, and it was the part of this project, right from modeling, analysis, design up to the detailing. So yes, so this is known as the Char Dham Yatra project. It's for the pilgrimage one because one of the tourist site is located around 3,000 meter from the sea level. It's so high, even if you go there, you'll have the breathing trouble because of the depletion of the oxygen. But it's a very beautiful site. So yes, there was difficulties in reaching those locations. So after this, there is a lot of economic activities, and it's a boost for the local communities there. So yes, this is the project outcome they have shared with us. The company name was WSB Global, and it has boosted the tourism activity in those areas. And yes, STAT is one of the vital products involved. So that's all. So that these are the two important success story I thought of sharing with you. These are the recently awarded success stories. Okay, now let's talk about like what we are going to discuss today. So I know that many of you are very new to StatPro. Before I go into further discussion, let me introduce like Stat. You might have heard of before, right? It's nothing new. But right now we have some larger solution called Structural Worksuite. Now this is not a product. This is a kind of bundle structural solution we are offering through a single umbrella. So let's see here. Say, for example, this is a huge building made of steel and concrete. These are concrete and these portions are steel, roofing shed. Here, if I ask you what are the things you are going to do here, first of all, you need to assert in the analysis is done. Design is done. Design means concrete design, steel design, then foundation design, then connection design, and finally the detailing. Now let's see what are the products that could be positioned here from our Bentley. STAD is the most vital product, as I mentioned before. It is used mainly for the complex structural analysis, be it linear structural analysis, nonlinear, doesn't matter, it can handle. After you have performed the structural analysis, STAD can also do the steel design very effectively. It can not only design the steel section, but it can also optimize it. Say, for example, you have chosen some initial sections and you have designed to find that, okay, is it okay or not? It will check that as per the codal clause, but also it will guide you. It will suggest you the most optimum section that could be used there. So yes, with STAD, we can analyze and design the entire structure, and especially the steel member, we can optimize them. After you design those sections, you need to do the detailing. Detailing is a very complex task, right? Because after you design, you have to sit with your draftsman, your one who is working on the CAD model and all. You have to exchange those information manually. Now, it was a very painful task so far. So over the time, we thought of like, why don't we add a software or product or application that can fetch the design information from StatPro and it can generate the CAD drawing. So that is the reason we have added something called Steel Auto Drafter, which will fetch all the section design from STAD and it will generate the drafting drawing. It's a very beautiful software, very small, but very useful. Then connection design, because connection is also very important, steel connection. So we have something called RAM connection, which is used for steel connection design. Concrete element design like shear wall, beam, column, even the column having the different complex shape like T shape, L shape, I shape. This can be used in RCDC. We have something advanced slab solution, which is for different kinds of flat slab, post-tension slab, a hybrid slab, or maybe the regular slab. So it's a dedicated fine element product for flat slab or any kind of advanced complex slab design. Finally, we have the STAT Foundation Advanced for foundation design. So you can see that in my entire structure, we have so many solutions needed. Okay. Now, STAT is one of the product, although it's the most important products, but you can't analyze and you can just be like, okay, I will use my Excel spreadsheet to do the design and deliver the design. Yes, everyone has got the Excel spreadsheet. That's fine, but you can use it for reviewing it, for verifying this. But if you want to rely everything on Excel spreadsheet and do the design, then it's very time consuming and it doesn't give you a smarter solution. So after analysis, instead, we have these applications which can further enhance your experience in your design workflow, and it will give you the total solution, right from design to detailing. Okay, so that is the reason instead we have something called the total workflow, and these entire things that we have shown you is coming under something called structural work suite. The structural work suite is not a product; it's a license that we are providing to access the different bundle of these products. Okay, you'll get the total access to this and give you a very smart workflow. Okay. So these are the structural worksheet that we have, and these are the products. There are different products we have. I have just shown you a few of them. So everything are well integrated. These are all connected with each other, and we can have a single license for this. So, for example, this is STAD for frame analysis and heavy engineering analysis for a complex structure. RCDC is for building design or concrete design. STAD Foundation is there. RAM structure is for tall building design. RAM concept is for post-tension and hybrid slab design, and steel connection design can be handled by RAM connection. Now, as all of you, I'll assume in all of you, right? Like the new to STAT. So STAT is a time-tested product. What do I mean by this time-tested product? It was developed back in 1985 or 86. I was not there at that time. I mean, not there within this company, but it was first developed in US and it was in the DOS mode, not in the graphical users mode. During that time, a lot of yeah, advanced users were using this. But after that, in 90s, they have started adding the graphical user interface so that you can operate it from graphics. Later on, after its success, Bentley has procured this product. And believe me, it's not only for small and medium business. This is used by different types of users, right from university to big companies like Jacobs, Wally Persons. We have Mott McDonald's, we have Petronas, we just name it. All the different big companies are using it heavily. So it's a time-tested product. It's not like the product we have developed overnight, reliable one. Second is the input editor. No other products provide this option called input editor. Any one of you are aware of this input editor, by the way? You are aware, right? You are aware? Input editor is nothing but a small, a kind of, you can say, command box where you can control a lot of things from the commands. Means it's a two-way traffic. Means you whatever you do in graphical user interface, these are logged in this input editor. This is just a text editor. And whatever you make the changes in this text editor, everything will be reflected in your system. So that's a very handy tool. So it can also do the advanced element analysis. It has a very great graphical user interface. It has got some open stat, open architecture. Open architecture is something like, say, for example, you want to have some very specific code you want to design, or maybe you want to design a very specific structure. Now, say for design code is not implemented for a very specific structure. But what will you do? You will analyze in STAT, export the result in Excel spreadsheet, forces and all, and you use your different formulas in Excel spreadsheet to do the design. Now you have to do everything manually. But this OpenStack is something very smart feature which will help you to integrate with your existing stat. All you need to do in Excel spreadsheet, you know the VBA program macro. You need to. There are some functions which are there in the OpenStack. With this function, you need to write your own code by which you can automate the entire process. You didn't have to manually do that. Maybe in some slides I can just mention it. Can I have a paper and a pen just to mention it? Just a small note.
Yeah, you can just do it off.
Maybe some points.
Okay. Sorry.
Okay. So then we have around 90 international design codes, including steel, concrete, aluminum, and everything coal formations. And out of them, most of the standard design codes are available as if, no, not most, all of them except for the nuclear code are available at free of cost along with your STAT license. Physical modeler based an approach by which you can quickly model any kind of finite element structure. And it has got a very powerful integration with different products like Revit, you just name it, like Tekla structures and so on. And it's suitable for any structure. So it's not restricted to any particular structure, like, okay, I can only do the building with that. It's not like this. You can model building, bridges, anything. So let's see. I have taken few of the important sectors, although these are not the only one. We have so many different background of the users who are working on different sectors, different projects. Say, for example, this is a building which is very much used. nuclear power plant or maybe normal power plant, anything. This is the transmission tower, bridges. This is industrial construction for the industrial shed, idle, renewable energy, infrastructure, oil and gas, cement, mining, heavy engineering, you just name it. So these are few of the examples I have cited here, but the examples are limitless. So there are so many different types of background of the users who are using stat. So why we can encompass so many different sectors? The reason being it's a very generic purpose structural analysis software. Just like your Excel spreadsheet, you can do it for your normal scientific calculation, use it for financial calculation, use it for normal day-to-day life, you know, some kind of scheduling. So a lot of things you can do in Excel spreadsheet, right? So there's the same thing. Instead, all you need to do, you need to know how to deal with this, and you can just model anything. Say, for example, I've taken one sector only, bridge. So within bridge, how many bridges could be possible? These are all the users model. This is the foot over bridge. This is the arc bridge, plate girder, cable stayed bridge, suspension bridge, and open girder bridge. So you can see within the bridge category, there could be different possibilities, different types. So these are the users model, and the users have used that for different projects for the bridge. For example, here you can see this cable stayed bridge. This is recently we have worked on for a user in Philippines. They have some existing bridge. Now this bridge is so it's a very complex bridge. These are all the cable element, and these are performed by the advanced cable analysis because these are essentially the nonlinear element. So for the material, we can deal with different types of material: steel, concrete, aluminum, and timber. For steel, we can further classify it as a rolled whole form. For concrete, obviously, it's a normal RCC, aluminum, and timber. And you can see that for steel and concrete, there are so many international design codes implemented, and out of them, obviously, the US, British, Eurocode, and in some cases Indian codes are also used. So these are all available. By the way, which design code you use? ACI, right? ACI, okay. Good.
Sepertinya SMI belum ada ya. Indonesian code, Indonesian code. Can
Indonesian,
we convert from Indonesian code to be library part?
Indonesian design code,
Yes.
steel code.
Yes.
Indonesian design code we don't have. We didn't get any such request from here.
2007, 2022 ya.
Let's see. What is the name of your design code?
2847 ya. 2022 ya.
SNI.
Sama ya.
No, we don't have. For steel, right? Or concrete?
Konkret, bukan ya.
No, concrete we don't have. Indonesian, rarely we get any request. Definitely, if we get a request, we know. But yes, I can pass it on to our development team. If we get significant requests, why not? So many intention design codes are.
2024, 2022. 19, kan 2022.
But mostly for big projects, you use ACI, right? Yeah, I heard that.
Yeah,
Both in Indonesian, Philippines, they use the American standard.
M ya. M.
Okay.
So if don't have, can we import from another library?
No, design code you mean, right?
Yes.
Design code or section, which one? Design code, if you mean that design code, then you have to implement it. Means how will you import the library? A lot of design rules we have to implement. Different clauses of the code we have to implement. So this will be checked. Yeah, so a lot of implementation we have to do. What you can do, these design codes, there are different teams. If I say, for example, American code, if you have to implement a lot of lengthy program, we have to write around a year or so it is required, and then testing is done. So what you can do, as I mentioned just a while ago, OpenStat, right? So OpenStat, you can import all the forces from StatPro and you use your Excel spreadsheet for defining all those, what you call it, the parameters.
So we use OpenStat, can import from another code. So can OpenStat integrate to something?
Yeah, OpenStat is already there. It is already there, OpenStat. I can show you. This is the OpenStat, okay? So OpenStat is a kind of API by which you can pull the information. For example, analysis result you want to pull. This is the member forces, for example. There are, say, for example, get member and forces, okay? So these are some of the syntax. Obviously, by seeing this, you can't write. You need some training on this. 1 day training would be enough. All you need to do, these are the libraries you need to know. And in the OpenStat, you can pull the information in Excel spreadsheet. Say, for example, you want to design a member as per your Indonesian code. Say, for example, steel.
Just like text editor.
Pardon me?
Just like text editor.
Yeah. Yeah, exactly. So what you need, like you need to know the end forces, bending moment, shear force, and all. So in the Excel spreadsheet, you write like different criteria of design, yielding, buckling, local buckling, global buckling, and all. So what you can do through OpenStat, you can automate those results. Means program would automatically pull those member forces information. You didn't have to manually copy and paste it in the spreadsheet.
Is it OpenStat for application API? API for offshore?
Yes, these are the API. A lot of information you can pull. Okay, now next is the analysis capabilities, which is a very important thing to understand. So we can deal with both the static as well as the dynamic analysis. Now, if I say the static analysis is a very straightforward, but if I say the dynamic analysis, it's something to do with when the mass is in motion, right? And this is one of the complex type of analysis. By any chance, any one of you doing the dynamic analysis? No need, only static, right? Okay. Anyway, just to let you know that we do have. In fact, for the static, we can further divide it into two different categories. One is the linear static, and second is the non-linear static. So what is the linear static? Linear static is the very normal. Most of the analysis that we do are the linear analysis. The response, displacement, forces are linearly proportional to the applied loading action. And the non-linear is something a bit complex and a bit advanced. For example, P delta analysis, where the response is not linearly proportional. Okay. So these are mostly to do with some kind of slender section, tall structure, tall building, and so on. So yes, just to let you know that instead we can handle both the type of analysis, be it linear or non-linear, doesn't matter. So in the dynamic analysis, we can further classify it as for say, for example, for the seismic, we can do it with the normal response spectrum analysis, and we can also use the time series analysis for our further seismic calculation. Now, for the other application of this dynamic analysis instead, which can be used for some advanced analysis. For example, machine foundation, you want to do. If you want to do the blast analysis, like you are working on a new project where you want to do some blast action for excavation or maybe blasting some rocks and mountains. And what happens? You have your housing system nearby, or maybe your site construction office nearby, or maybe existing structure nearby. You want to see that due to this blasting action, how your existing structure is getting impacted. This is one of the very common type of analysis a lot of our users use instead. So what you need to do, we need to simulate it through the time series analysis, just to see that okay, my blast site is around 500 meter, and how the waves are getting transferred and hitting my structure, and if it hits my structure, what is the response of my structure? So we can do it through the time series analysis. And also like earthquake, obviously, this is the most important analysis we have to do. Now, these are all the type of analysis which is heavily dependent on dynamic analysis. So these are the summary of the analysis capabilities. So we have linear, that is the static and dynamic. Non-linear, we have and geometric nonlinear analysis. So we also have the linear. From the very basic linear static analysis, we do have a lot of advanced analysis. So may I know that out of this analysis, which need? Which type of analysis you need? First one, linear static. Okay. So linear static, most of the user use because it's a very basic type of analysis, like most of the structure, 90% of the structure we come across with this type of analysis requirement. To some advanced type of analysis, then we have something called geometric nonlinear analysis, nonlinear cable analysis, dynamic steady state analysis, advanced buckling analysis, synthetic time. These are some of the advanced analysis which is covered under Stat Pro Advanced. Now, please be noted that the Stat Pro Advanced license can also give the access to the Advanced Concrete Designer. Okay, so that is very important to note. License. Okay. Okay, so now let's see that what is the status of our Stat Pro, means where we are. So Stat Pro has started its journey long back. Now, I have just shown you the evolution or the different time where the stat has undergone significant changes. So it's from 2007, but it was started its journey long back. I've just taken this one from 2007 because at that point of time, Bentley acquired it and it was started to penetrate into the market very heavily. Now in the 2007, we have a Stat Pro P8i and Select series. And then we have the Connect edition. And after the Connect edition, we have Stat 2020, 23 and 2024. Okay. So the current version is 2020, 24. So may I know that which version you are using?
I use first run is start 3.
Stat 3, yeah, Stat 3 is long back. Yeah, exactly. So you're an old user. Yeah, Stat 3. Even before this one is Stat 3, but I didn't show this because it's long back, around more than 20 years back. So yes, so we have a long journey and it's a time-tested product. Means why I have shown this because a lot of users across the globe provided their feedback, provided their suggestion, and we refined our product. So it's a very reliable one. Now in the Connect edition, which is the latest, not latest, it is something like this where we have done a significant migration. But I'm not showing the Connect edition here because we have 2020-23, which is the latest one. Let me just take you through this because before I go ahead, these are some of the design codes that we have recently added. Okay, and among them, ACI code is there, ACI 60, 16, and 22, and most of the other intentional design codes we have added. Now, if you have used the older version, so please be noted that in the Connect edition, we have added a lot of important things. Like we have added the physical modeler designer, advanced reporting. Edina is another product, element product I'll show you, which is integrated with our existing stat. We have the steel auto drafter, which is connected with our existing stat. RAM connection is a very advanced connection, steel connection design software, and advanced concrete designer. So for you, advanced concrete designer is very important to know. Anyway, so the latest one is 2023. We call it the V2023 and V2024, almost same. So in this one, we have included the Edina Stat integration, advanced flow load, advanced report generation, custom steel database, and effective length factor calculation. Okay. So many things we have added. I think if you're new to this, you can't find the difference because everything would looking new. So just showing you if you have any experience in the previous version of Stat, then you can understand like what the difference we have made.
Sorry, you mean
Yeah.
this model in the start or CA, connection addition packet. Or
Which one?
this module or this module,
Uh-huh.
there is on start for connection packets or out of the
Oh, StatPro connection, you
Yeah.
mean, right? Okay. Now, StatPro connection doesn't come like this. Let me show you in the last slide. Maybe if I have. This is the StatPro Connect edition. It comes with the basic and also with the advanced, but we have the partially available, means limited feature we have. Okay. Limited feature means not all the connection templates would be available. You can design few of the connections, but not all of them. And drawing won't be available to generate. So a lot of things are restricted there. So a very basic features you'll get. But if you want to use the connection design, you need to use this structural work suite license that will give the access to everything. You can take the snapshot of this.
Jadi structural work suite, sorry. Itu is the access ya, access ya.
Yeah.
Access ya.
Yeah. So if you have the structural work suite, you can access the full version of RAM connection.
It means if we buy structural work suite, we
Mm.
can put take every item, every interface from others like start connection edition.
Yeah. No, stat you can get. Stat you can get in basic also, advanced also. But apart from stat, we have other products like stat advanced foundation, which is the other application itself. RAM connection is other software. This is other software. So, and for example, RAM structural system is other software. So these softwares can be available if you use structural work suite. Okay, now I'll just show you maybe some of the salient things. Just one moment. Okay, now let me show you that we have done a recent enhancement in our flow load distribution by which we can apply the flow load on any type of geometry, be it this or any kind of geometry which doesn't have the extreme beams, we can still apply them like this.
I have one question about
Yeah.
tributal area.
Mm-hmm.
Can
Yeah.
StatPro determine tributal area for specific geometry? For
Yes.
unspecific, like tubular, like
Tubular.
yeah, I don't know. Unsymmetric.
Yes. That is the
Yeah.
one that we have mentioned here.
Automatically.
Yes, previously we could not, but right now, any kind of geometry, be it pentagon, hexagon, or any irregular symmetry, we can define it.
And how about loading? Loading for tributal area. Can StatPro show what loading
Yes,
for specific?
this is loading.
Yeah, I mean that. How about tools? How about the tools interface? Tools interface on StatPro. How to input?
See, this is the one. Let me show you.
How to input the loading? It's a standard like a two-way, one-way.
Yeah,
Right?
I'm showing you. Let me show this one. Where I have. I have the model. I can show this. Yeah, so maybe I can show. So this is something called enclosed flow load zone. Okay, this is we newly added it. We first need to define the boundary of it. Okay, and then we need to define the load intensity, and whatever the boundary we have defined, we need to select that boundary and define the direction of the load. You can see the tributary load is applied to this one. Very powerful and helpful feature for any kind of irregular geometry.
Okay, thank you.
Yeah. So then we have the EDINA integration. So some of the features, if you think that advanced feature you mean, which is not available in STAT, that can be catered by EDINA. EDINA is an advanced finite element analysis solver, which we have procured it from a different vendor, which is a very pioneer in the finite element industry. It was developed in MIT in US. This is the background, founded in 1986 by Arjun Bate. You can find his lecture in YouTube also on finite element, a very renowned personality on finite element. And you can simulate anything, not only the normal structure, anything. So for example, this is a dynamic analysis of a bridge, which is having some nonlinear components like this tension only member. Now you can see how nicely you can simulate the behavior. This is a kind of solar structure subjected to some wind flow. So we can predict like what would be the turbulence, and due to this turbulence, how my the response pattern would be. So this is another nonlinear bridge. If you walk on this bridge, how the bridge would behave, you can simulate like this. So very powerful software. EDINA. Yeah. There's a blast analysis. For example, there's a blast. Instead, also we can do, but EDINA we have some advanced feature also. You can see these are the collapsing, and this is the simulation of how it would look like.
Analysis design by StatPro and EDINA import StatPro data.
No. EDINA is not for design; it's for analysis. So after you model it instead, you can export it to EDINA for performing those analysis, advanced analysis like different nonlinear analysis. And then you can see that what is its behavior. Okay. This is another one, very interesting. Water retaining structure subjected to earthquake. You can see when the liquid is carried or liquid is retained, what do you call it? Sloshing effect, right? Now this is very nicely simulated in EDINA.
And can EDINA integrate to StatPro data?
Yes, it is already integrated. I have a one video on this. I'll show you. This is a kind of plastic deformation due to some fatigue or cyclic loading of a steel section. You can see some contour would be developed here. Yeah. And if you want to do some buckling of the metal sheet, this is how we have the integration with STAD. You have to model everything in STAD like this, and then you can take it to EDINA. Okay. So what you need to do, you need to first see or set the model, and after that, let me show you the model. This is the model you have. Okay, instead. Now let's take it to EDINA. Go to export. There is something EDINA. You can see this is the EDINA. Let me again pull in. This is the EDINA. Okay, and you have to export it. Please remind me to carry this. Now we are in the EDINA, we are inside the EDINA where we will try to add complex analysis criteria.
Import from Sapro and
Yeah, yeah. So we are working hard. Even if you needn't have to go to EDINA in the near future, everything would be available inside STAT. So that's our future technology we are working on.
Maybe Edina like ANSYS.
Yes. EDINA is a competitor of ANSYS, Abacus. These are advanced finite element software.
Can Edina analyze for fluid analysis?
Yes, fluid. Yes, this is the fluid we have shown you. CFT, right? Wait. This is a CFT, computational fluid element. Okay, so now coming back to STAT, we have a lot of things to discuss on STAT. Now, first of all, let me take you rather than that, the normal STAT and show you the workflow. Before I go into STAT, let me show you. First, let's go to the STAT. Just discuss a little bit. So, just a moment. So this is called Advanced Concrete Designer. We have recently, not recently exactly, it's been several years, but in Connect Edition, it's all integrated, called Advanced Concrete Designer. So there we have several international design codes, including Philippines, US, Indian, all. Now you can see here this Philippines national code was not previously included. After getting a lot of requests from the user, we have implemented. So it doesn't matter if you want your code to be implemented, you please write to us, to me. We'll send it to our development team. They will understand the importance and consider it for future implementation. And then we have, it is a very interactive design where you can see, across the length, design reinforcement provided reinforcement versus the actual reinforcement. You can see the entire graph, and it not only do the column and beam design, it can also do the shear wall design with the boundary element. So this is the drawing and bending detail, and you can see the drawing is very top notch. It will deliver you the drawing as per the industry standard. This is the cross section of one of the shear wall. For column design, we have several options. Okay, and previously we could only handle the very regular column like rectangular column or maybe circular column. But over the time, we realized that our user need to use different types of columns. Could be T, L, I, or any kind of arbitrary column shapes if you want. Now, if we don't restrict only to rectangular or circular, but also you can design any kind of column geometries. So this is the column elevation by which you can see the different reinforcement representation of this column. And this is the beam detailing. So this is how the beam detailing works.
STAT Pro Connect Edition can provide for report column.
Connect Edition what?
STAT Connect Edition
Uh-huh.
can provide, can give a report for
Yeah.
schedule.
Yeah. This is RCDC.
RCDC.
Yeah. Not
basic for STAT Pro basic.
No. See, Stat Pro has, as I mentioned, Stat Pro has got its own internal concrete designer module. This one. Okay. This is the concrete designer module which comes inside Stat. But these are for a very small structure like pipe rack and all. For building one, you need to go to advanced concrete designer. This one. Okay, and it will take you to the RCDC. RCDC is another application. Okay. So it will take you to the RCDC.
So it means if we don't have RCDC, we can.
No, you cannot.
Oh.
You have to have the RCDC. So RCDC comes with the advanced stat license or work suite. Okay, I'll show you quick workflow on this. Maybe before that, let me give you some quick modeling examples on stat. Let me show you this one. You are doing dynamic. Any one of you are doing the dynamic analysis? None of you, right? Okay, then I'm just going with the very basic one. Yeah. So
I'm sorry, Mr. Purkayats.
yes, go on.
In Stat Pro and other programs in Bentley, can we analyzing my structure model in trial version or must in full version?
Can you come again? You want to model the channel section, you mean?
Yes.
Channel sections for steel. Can you please type your question? And no worry, I'll just take your question. Just type your question in the chat box so that I can understand what you mean by this. I'll definitely answer your question. So let's wait for him. What is? Are you typing your question?
Diketik aja, Pak. Silakan diketik aja, Pak, chatnya.
Okay. So please follow the chat. They are writing some questions on chat. Now they are writing in your own language, so I could not understand. So see what to. Oh, there's another question. Okay. No, he will write. Yeah, excuse me. Those who are online, they have asked just a question a while ago. Can you please write your question in the chat box?
Bapak Ibu diselesai ya, absen.
Hello. Pardon me?
Yes.
Oh, can I analyzing my structure models in okay. Trial version. See, okay. So trial version, if you say trial version, we don't restrict anything. Trial is like we are giving you as a trial for certain period. It could be 7 days or 13 days as an evaluation license. Now this is just to let user know how it works. We don't restrict it, but yes, after the expiry of the trial period, you would be you would not be allowed to use that product. How to register the trial version? For that, you can reach out to our sales team or channel partner. They can advise you. Okay, so I'm just imaging this. Okay, now let's see this one. This is a very simple structure that we have, okay, for beam and column. And modeling is very simple. We have so many things to use overview of them. Now, if I go to the plate and solid element, okay. So if I show you what are the elements that we have used here, we have used this plate element and we have used the member, okay. Plate and member. Now, what are the properties? Then you can see here a lot of properties we can assign. For example, if I go to this prismatic one, rectangle, T, trapezoidal, tapered section if you need it, for example, some tapered tube you can define, and some other sections if you want, you can define. So we have so many standard and non-standard sections possible. Apart from that, if you are working on any steel structure, you can go to, yeah, hello, excuse me. So this was your question, right? If I could answer, understand properly, you had some question on channel section. Is it related to this one trial version of StatPro? If yes or no, please let me know. Okay, now we also have some standard steel table. Okay, so steel table means some of the steel sections which are specified under the country specific code and standards. For example, if you go to the AISC handbook, you can find all the steel shapes and its databases. So we do have everything in our database. All you need to do, you need to select the right section and you need to assign it to the respective member. Okay, so here, for example, what I have assigned is, if I double click on this, we have assigned some rectangular sections, simple rectangular section. Now this is a concrete section, so I'm not using any steel structure sections here. And then we have user provided table. Please follow this. It is a very powerful feature that we have. Let me show this here. If you have any other section, for example, star shape, or maybe any other arbitrary shape, which is not a standard profile shape, you can create any random shape from here. Say, for example, this one is a kind of general section. If I give it like this and define the polygon like this, 0, 0, 0, -1, -1, 1. Sorry, 0, 0, then 1, 1. So, for example, this is a section shape we want to analyze. You can use it in your structure. I'm not going to assign it, but just to let you know, any kind of shape, if you want, you can assign it for your analysis. Be it regular or non-regular, doesn't matter. Okay, so here we have something like this. And also, for example, if you are into a project where you need to use different grade of material, not like regular steel and concrete, for example, glass, or maybe some carbon fiber or anything, you can have it. You can go to this material. There is some standard material database, but still you think that, okay, I want something which is very different. You can go to this create, and there is something you can see. We have some standard database, but apart from that, if you want to add your own, you just name this. For example, I can give it like glass, for example. Just name it as a glass. You need to define those material properties like Young's modulus, Poisson's ratio, damping factor, shear modulus, thermal coefficient. You can just change those values and add them. Once you have done this, this would be saved in your system and you can use it for your structural analysis. So that is the reason it's not about only steel and concrete. If you want to analyze, you can also use any type of custom material. Okay, now that we have okay, another important things. Any question online? Hello, those who are online, do you have any questions so far? Can you see if they have any question?
Bapak Ibu silakan. Ada pertanyaan? Tanya langsung aja, Pak. Nanti boleh, Pak, dalam bahasa Indonesia kalau sungkan nanti ada kita translate dari sini. Terima kasih, Pak.
Okay. Okay. Now, if I go to the member specification, we have so many options. We can define a member as cable, compression only, tension only, truss, crack property, release. Now, out of them, few of them are very important and sometimes very useful. For example, tension only member for tension rod, rope, Truss member for member which can carry only the axial forces. Crack property. If you think that your concrete has developed some crack and it has got some reduced section property, you can define this by reducing its effective stiffness. And during this analysis, it will use the crack property, effective crack property, to perform the analysis.
But can you show how to do the simple cable construction by staff?
Yeah, the simple what?
Construction cable.
The cable section.
By staff.
I have it already.
Is it simple or difficult?
No, very simple. Hold on.
By staff pro connection or LCDC?
Confusion. Hold on. What you want in cable? So many cable I have. Wait. I'm showing you the simple one. This is a kind of tower which is supported by these cable elements. Okay, these are the cables. Now, what are the things that we can define or we have defined? Specification, initial tension of the cable, okay, or the unstressed length we need to define. And we need to define it as a cable member, if our member tensionally member. And in the analysis, if you go in the analysis, there is something like perform cable analysis. So there you need to select like what type of analysis you need, advanced cable analysis or modify Newton Raphson's. Generally, you can use this advanced cable analysis. This is one example, a little bit complex. Let me show you.
Prospect has a typical model. Default model.
No, these are the model I have created.
Oh,
These are not stat model. These are for every other seminars I created. You can find it inside stat. Say, for example, this is a very nice example. Let me show you. So this is what, can you guess? Any idea? Did you see any kind of glass glazing which is supported by cable mesh, just like our tennis racket? Okay, let me show you. Wait, I have it maybe. Yeah, this one. Entire glass is being rested by this cable mesh. And it's not that easy to simulate, because if you do the normal analysis, it will get the instability warning. So you need to use some pre-tension cable element and do the advanced cable analysis. Now this, when the wind is hitting, the entire load of this glass is being resisted by this cable mesh. So let me show by this model. So this is the self-weight of the cable and the glass. This is the wind load. And as this is a nonlinear analysis, I have done the combination through the repeat load. Now let's run the analysis. So let's take the combined effect. Just a moment. Let's see. The huge displacements we have. Let's see if I can get some. Or maybe if I see the tension of this. These are the forces. And this is the displacement values. So let's do one thing. Let's check another example. A bridge. Uh, Cable stayed bridge, I think, yeah. Cable. So this is a cable element. These are all cable element. You can see member cable, and this is the initial tension. And after the analysis, I've already done the analysis. Let's see. You can see the displacement and everything. And if you want to see the forces developed in the cable element, you can change this diagram by changing the scale. But yes, you can see all the forces if you select them individually. Here, if you see, not here, maybe. Reinforce, yeah. Reinforce, ground. Here, yes, this is the axial force, okay? Affects the axial. This is the axial force for the cable element. So these cable elements are non-linear cable element, and these elements we have typically modeled in STAT by the non-linear cable element. You can see it. Another last example I'm showing, it's also a nice one. These are all the models that we generally create. I have created it for different, user demonstration and all, and user examples. Just one moment. So, so this is a plate which is rested by the cable.
Yeah.
So this is also cable element. Now, if I run the model, I've already run the model. is a plate element, and these are the cables. You can see here the cables. So by this we can see like how these are hoisting. And you are in the offshore, right? And one important thing you might be needing it, I'm very sure you'd require it, is the lifting structure. Lifting. You need that lifting of different offshore equipments. Yeah, this is okay, Lal. I have this. We have a separate webinar on this lifting structure through this cable analysis. Just a minute.
How about section report?
Hmm?
Section report is okay.
Section report?
Yeah.
Yes, everything. Yeah, coming. Wait. So, for example, this structure is being lifted. Okay. These are the cable members. Okay. Now, if you do the normal analysis, it will give you instability. It will be swinging like this. So it has to be done with the member cable. After you do this, you can see the forces and its displacement, everything. And it is very much used in the offshore structure. Means whenever you are in the port and all, you need to hoist different kinds of container and equipments. You need to do this lifting analysis. A lot of our users are using this for the offshore structures. Any question? Any question you have? Okay, let's. Those who are online, do you have any questions? Hello? Hello, hello, hello. Am I audible?
Silakan yang bertanya, langsung aja Pak.
Okay. Now, in the building, as I mentioned, we have so many options. Now, let's quickly see the different support option that we have. Then we will perform the analysis. How much time we are left with? 1 hour? Okay. So we have fixed, pained, enforced bar, everything. And also it is, if it is resting on any plate mat means raft, which is resting on the soil, we can also model this one. Okay, we call it the tension only, compression only. And this raft is a very effective, this one, foundation, plate mat. Need to define the spring stiffness through the separate modulus and define the direction of this spring action and define its stiffness. Okay. Now in this model, what I have done is it's a pretty straightforward. I have used the seismic load, not the dynamic one, static procedure I have used. Now in the static procedure, you can use the IBC code, Indian code, and other international design codes and define all the parameters. And if you are in the Indonesia, and if you're following the AC code, doesn't matter. There is something called FA and FB, which you can manually feed them. And anyway, so where we have started, yeah, this one. So once you have done, you can define the seismic loading action. And not only the lateral one, you can also define the accidental torsion and natural torsion. So then we have the dead load. It's a flow load option. And these are the load combination. Yes. Different load combinations. Now, one thing you just need to know that we have different types of load combinations. One is automated load combination, and one is the manual way. I would prefer you to use the automatic load combination. If you have any any code specific load combination want to generate, we can use it directly from here. Automatically load will be generated. In case you think that no, these codes are not available, for example, Indonesian, or maybe you have your own specification of load combination, you can anytime create them and save it as a future template. Say, for example, here we have the standard. This is a kind of database. You can unlock this and create your own set of code and give it a name and give the factors like this 1.5. So whatever factor you want, you can keep on adding, and you can keep on adding the rows like 1.2, 1.2, 1.2. So you can, after do this, you just commit and save it. I'm not going to save it because I have several others custom code added. So similar to that previously, I have added similar kind of custom code for other presentation. You can see these custom codes are already added. So whatever the custom code you have added, you can just select as these are saved inside your stat for your future templates. And later on, you can generate the load. So this is a very powerful feature. And see, this is a very simple model. That's the reason I didn't have to generate too many load combinations. But if it is dead load, live load, wind load, earthquake load, temperature load, yes. So
It means we have to send my code. We have one point factor, number factor. We can input this.
yeah,
and we create as a new.
yeah, exactly. So maybe 50, 60 load combination would be possible. How will you generate manually? That's the reason we have this automatic load combination for quick generation. Okay, now let's see the type of loading that we can do. What are the different types of loading we have? Self-weight, nodal load applied on the node, member load, area load, flow load, plate pressure load. If you are defining some physical plates, you can apply on it. If there is any thermal behavior, temperature load you can define. Seismic load, obviously, time history load for dynamic analysis, wind load, snow load, and finally some response spectrum load. So different kinds of possible load are available. Okay. Even if you want to apply the hydrostatic load for retaining wall and liquid retaining structure, you can define it. Anyway, so here we have delivered or generated all those different combinations. And now we are going inside the advanced concrete designer. Let me first analyze it. Okay, before I analyze, let me show you that if you click on this analysis command, you can see perform analysis, P delta, cable analysis, nonlinear, geometric nonlinear analysis, buckling analysis, and so on. So you have all the different set of analysis capabilities. Okay. So the most commonly used is perform analysis, that is linear elastic analysis. Okay. So I have already defined it. I just want to run them. Okay. So this is the post-processing response. Okay. If I show by the animation, you can have some feel. This is for dead load. This is for earthquake load. I have increased the scale. That's the reason it is showing like this. This is the live load. Now, whatever the values you want to see, you can see it in the post-processing file. If you want to see the maximum values, you can see them. Say, for example, bending moment of any member, if you want to see, for example, this one. You can see it here, or maybe in the output file, or in the post-processing file. Also, you can see it in the post-processing file. For example, if you go to this guy, beam forces, you can see here. And there's a nice little example I'm showing. If I go to this beam stress, here you can see, for example, this one. You can see the color pattern changes, right? This is because if I just drag this slider, red means tension, blue means compression. Or let me see, like convention, maybe blue is tension, red is tension. You can see the convention. So this convention, if you follow, you can see that the reversal of forces where it would be, these are all the normal forces, fiber stress, okay? You can estimate the fiber stress. And all the corner fiber stresses would be plotted here. So this is very helpful if you want to see like, okay, where is the maximum fiber stress will be developed if you're using maybe non-standard section. So yes, from the post processing, we can see some other summary like maximum value, minimum values, reaction, beam result, all those information you can get it from there. Now, once you are done with this, you can also generate a very detailed reporting. Just a moment. So this is the report, and you can see what are the things you want to include or exclude. You can put it in the report. For example, I want to include the reaction. This reaction is included, and if you see this one, see all the reaction. One good part is you can directly export it from to Excel. No need to copy and paste. We go to OK. It will open the Excel spreadsheet like this, and you can get it everything in the tabular format. Okay, that's fine. Now let's move to Advanced Concrete Designer. So we have already performed the analysis successfully. Now let's go to the Advanced Concrete Designer for concrete design. So we have ACI, for example, columns and walls. Okay, so this is the floor that we have section. I mean, we have imported from Stanford. Now you can see different elevations are mentioned. So we have 3-story building. This is the maximum story level. Now there we have different option for the design settings. You want to do the ductility designing, or you don't want to do the normal ordinary frame, design. We have the live load reduction, effective length factor. It will calculate automatically. You can optimize your design. And, if you want to design it for the shear wall, because the shear wall design would be applicable if it qualifies for the shear wall design. What is the qualification? That depth to breadth ratio. By default, it is 4. If you want to increase or decrease, then all the what the column should be treated as a shear wall. Now this is the crack width. If you want to include, you can switch it from here. Okay. So yes, almost all the settings I have taken is a default one. And there's also one more thing, design with the boundary element. If you have the boundary element, it will also design them. So click on OK. So here we have already imported, and these are some of the reinforcement settings like minimum column ratio, shear wall ratio, the type of reinforcement that you have, what are the different reinforcement you want to use for the column, for the secondary reinforcement and all. You can define them from here. And you can also define the different zone of reinforcement. If it is a bigger column, then you might have the steer up in 2 or 3 different zones. So we have the settings to define different zones, zone 1, zone 2, zone 3, and so on. So finally, the detailing. In the detailing, you need to define like what are the things you want stat to or RCDC to display in the drawing. You want to display the material property, lap length, continuous section should show lap length at each level, and so on. So now we are going to perform the design with this. I've already done the analysis, so taking all the result from the analysis. Now let's do the design here. So these are the members already designed. Now you can see the status by this color code. If some of the members or the elements are failed, you can see it in the red color, or else if it is a green, these are the passed. So for example, I am taking this one. This is a shear wall. Let's see the quick section. So this is the shear wall section. And let's see, like we have a redesign section is there or not. This is a shear wall section. Now here you can, let's see this guy. If you want to change the grade of the concrete to see that, okay, how it works with the different grade of concrete and steel, you can anytime redesign them, okay? And you need to just click on this redesign and see how it performs. Once you're done, you can accept it. And there's a very beautiful feature for column as well. Let me show you. If you go to this interaction surface of the column, you can see the entire interaction drawing generated. This one. That is the axial force and the biaxial moment interaction.
Yes,
Yeah.
LCDC report.
Pardon?
LCDC report.
Ah.
LCDC report.
RCDC report.
LCDC.
RCDC report. And go to this redesign section. This is for a column, okay? Now here you can see that apart from rectangle, we do have a lot of other options. For example, capsule, or maybe T-shaped, or any other polygonal shape maybe. For example, if I want to define anything of this sort, number of edges like not 5, it is 6. I can have this one. Now, these are the different kind of sections you want to redesign. If you click on this redesign, it will immediately give you the design ratio, okay, capacity ratios, so that you can understand whether it's a good or not. Okay, now let's go back. Wait. Now within this, I'm just keeping it as a rectangle. Now within this rectangle, if I want to change the size of this, maybe 20 inch instead of 70 inch, I can make the changes. Concrete grade, steel grade, everything we can make the changes. Now another very interesting thing that we have is change dia bar. Say for example, these are all design dia of the bar, design bar dia. And if I want to make the changes to them instead of 4 mm, say for example, I want to just check like for the corner one, I have to apply 6 mm. So these would be replaced with a 6 mm. The moment you change this bar dia, you can see that this design ratio is no longer available. So what you need to do, you need to go to this redesign one. And you can see the ratio of this capacity ratio. Okay. So by this way, let me again show this one. So by this way, you can use or change the existing bar dia. Okay. Say for example, you have an existing building and you want to see the strength of this existing building. This is the existing building and you have some bar which you need to change. Say for example, this building, it is a 30-year-old building. You want to evaluate how it will perform. Now, you have to see that in the existing building, you know the size of the column, you know the number of reinforcement and the size of the reinforcement. Now, with this existing information only, you want to check the capacity. So for this, you can change the size, you can choose the bar that you want to use, and you can add those bars here by using this. For example, I want to use this 10 mm bar. Okay, I've changed it. Now, after you change it, there is something called redesign. If you redesign, if everything is okay, it will give you the capacity ratio so that you can understand that, okay, your existing column is good one for this existing load. So anyway, whatever changes you make, let me, last time I want to show you another interesting thing. Whatever the changes you make in the size, say for example, 25 mm size you want to change. And you can get a new capacity ratio. You click on accept. You can see here, this size has changed, right? Now, the beauty here is once the size has been changed, the stiffness is also changed, right, in your structure. So we give you the option to again create a new stat file for this updated stiffness so that you can check that, okay, due to this change in relative stiffness, how the force distribution would be. So you can run the stat file again, come back to RCDC for last time to see the compatibility, if it is okay or not. So yes, now then let's see this one in the report. We have a lot of options like detailed drawing. For column, we have so detailed. Let's see this one for, yes. Yeah, stat 3.
We use test editor.
Yeah. True. It was in command, mostly command prompt.
Yeah.
See the these sections are designed. Okay. Now,
Next start pro can draw shop drawing.
also,
Next maybe start pro interface can draw shop drawing.
yeah, we can draw this one. Yeah, this one.
Detail drawing. Shop
It-
drawing.
This is the detail drawing. You can save it in that format. Save the project. You can save it in the DX. Okay, I have to save the project anyway.
Okay.
Yes.
Yes.
See, this is a DXF. You can open it in AutoCAD.
Yeah, okay. Tekla?
Yeah, DXF can be
Okay,
opened in
Tekla.
Tekla. But Tekla, what will you open it? The concrete detailing. Tekla, Tekla can recognize concrete, recognize steel, right? So yeah, you can open it AutoCAD, MicroStation, Pro Concrete, Pro Structure, Traffic, or Revit. You can Revit concrete can, I don't know. Revit I have never used. Steel I know that Revit can recognize steel section. But any software which can recognize DXF, you can open it. And finally, very important thing is bar bending scale. This is a very painful thing to generate. So you can generate the bar bending schedule from here. Say, for example, this is the detailed bar bending schedule with the cutting length and all. Okay. And finally, you will get the bill of quantities. You give the rate, shuttering rate, plan area, BOQ summary. Let's click all of them. So everything you are getting.
A to Z. A to Z.
Yeah, complete A to Z. And this is just for column. We can also do it for beams. We can also do it for shear wall and so on. Okay, now that we have done for the beam and column, let's see if I have the floor, how to design the floor. Right, in RCDC also you can design the floor, but the normal floor. But if I have the complex floor like with model with the plate elements, we can use the RAM concept for this. Same type of structure, but in this one I have modeled with the plate elements. Plate element should be used for any kind of complex slab like semi-rigid diaphragm or maybe flat slab and all. So all you need to do, go to the advanced slab design, and I have already defined this slab. Maybe I can show you this one. This slab I have created, and from there I am exporting it. Yes, please. Anything wrong? Okay. Exporting it to RAM concept. So this RAM concept is a very state-of-art product for any complex slab design. And then we want to perform the analysis and design. Okay, I have imported the seismic. Let me check with the normal one, just one more. Just want to show with the dead load, then maybe some complex slab we can show. Yes. Okay, and if I want to design the reinforcement, I can define some strip boundary because reinforcement is designed in a zone wise in a slab. Okay. Now this is the design strip, and finally I'm going to define the design. These are the reinforcement, design reinforcement. If I want to see this, it's like this. So this is a slab info. You can fine tune this by changing different zones, different strip parameters, and you can fine tune the reinforcement detailing. So this is the final design status, like where it is passed or failed. If it is failed, you can use this audit cross section at any location to see like what is the final status of the design. You can see a complete calculation here. Okay, complete calculation. And the clause that is responsible for this, you can find it here. What are the different scenarios if I want to check this one? Okay. Just one moment. Strength design. You can see here. These are the different checks as per ACI 3198. So this is the final status or the clause for which it is failed. You can go to the ACI code and see this. So yes, we can get a complete solution for this kind of, and not only that, this is the normal reinforced slab. If you can also design the post tension slab. If you want to use the post PT slab, you can use it. And after this, you can also do the lot of other kind of checks here. For example, load history for creep and shrinkage effect. You can simulate it here. You need to define the concrete property, and it will perform the long-term deflection due to the creep and shrinkage effect. And then we have vibration. Say, for example, for floor slab, you want to simulate for the footfall action. People are walking on this, they will impart vibration. So we want to see that it is within the acceptable limits or not. So we have some options to define all those footfall information like minimum footstep frequency, maximum footstep frequency. It will simulate and give you the responses. If you want to see the deflection, for example, maybe if I can show this. Deflection. Wait. Yeah. So if I zoom this, you can see the contour and the profile. I can fine tune this. Let me see the intensity. Like this, you can see different types of contour. And that would give you some idea like deflection pattern. And these are the different deflected values. So these are complete solution for different complex slab if you have. And finally, the footing. No one is from steel industry, right? All are from concrete. Okay, so that's the reason I'm not showing the steel here. So here, finally, if you are done with everything, you can go to Stat Foundation Advanced from here. So these are all Stat Foundation. Maybe I can show you one example on steel also. Already. This is for the Stat Foundation. So you can launch everything from here only.
Berarti sudah mau kayak gini kan? Sampai satu lima dulu. Sekarang Pak Willy yang pakai. Oh, pakai.
So these are all the support reactions imported from stat analysis. Okay. Say, for example, you want to design the foundation. So we have different options. We have isolated, pile cap, mat, combined, octagonal strap, even the machine foundation. And the design code that we support are US design code, British, Indian, Australian, Canadian, and so on. So let's see some US design codes. I'm using only the isolated footing. You can use it for mat, pile cap, combined footing, and many other.
When design foundation, which one better in using formulation or attest or Plaxis?
Plexus is different. Plexus is very
Maybe
different.
FS
means?
EFES, software for design. Maybe design start from.
Oh, see, Plexus we can't compare with Stat Foundation. Just like Stat, we can't compare with Edina.
Yeah. Oh.
Same thing as Plexus is a
Safe.
finite element. Oh, SAFE. SAFE, right?
Yes.
The competitor of SAFE is RAM concept. Okay. In RAM concept, we can simulate plate mat. In Stat also, we can simulate plate mat, but RAM concept is much more advanced for mat foundation design. A lot of options we have. Okay.
Design piling can use that combination.
Piling?
Okay. Yeah,
Pile cap, we have this.
Pile
We design is a drill pier. This is pile cap we have. I'll show you a few of the examples. So here we can have the concrete property, cover and soil bearing capacity. You can, just one moment, let me pull in. Soil bearing capacity, soil surge, depth of water table, shear strength of the soil, everything you can define. Footing geometry, we have the option to calculate dimension or set the dimension. Calculate dimension will calculate the dimension for you. And if you use a set dimension, then you need to define that, okay, this is my dimension. Program will check that with the existing dimension, your design is passed or failed. So generally we suggest calculate dimension if you don't have any restriction in the area. So sliding and overturning check is also there, which I will use as a default factor. So if I go like this, let's see.
Yes. Pakai sat. Sambil. Okay.
So this is your design that is completed. First of all, it will do the sizing by using the service, service load condition. And then it will find all the different size from the soil bearing capacity and the service load condition. And then the design calculation for the strength level. Okay. So it will check both the service level and the strength level. final footing size, stability check, and this is the punching shear check. And you can see all the different formula and codal clauses are reported. And this is the reinforcement program is calculated from the ACI code. It's very detailed, okay?
Very good.
And we are also developing further in the next week. We'll have 2020-24 whose interface would be completely different. And same way, we can also design the mat foundation. Okay, mat foundation for this. So any questions so far? Then I can go quickly to a steel structure.
How about foundation report?
Foundation
Yeah,
report.
bar bending.
This one, bar bending.
Yes, yes.
No, here we are not reporting the bar bending now. So, any question you have? Anything?
Ya, Pak, ini saya bekerja ini ya, setelah dipakai, desain kan dikerjain tuh. Yang butuh apa tuh? Sudah kan, Pak?
So if we buy the Start Pro Advance, we got the line connection.
Yes. So this is again, I'm showing, and you can take a time. Wait. I'll also show you one of the very important thing on integration. Okay, just one moment. Just give me a break. Take a deep breath and come in. You see this one?
It's only partial.
Yes. With the existing stand, if you want the full access, you need to have the Apple Works. Partial means you have limited connection. A lot of features are restricted, like drawing could not be generated.
Ya.
Trans kalau beli trans kita nggak dapat rem.
Itu dapat cuma parsial.
Oh iya parsial ya.
Parsial ini
Iya.
sampai mana?
Kuning itu ya.
Iya.
Kayak gitu sih parsial sih yang mana?
Iya.
Kuning sampai biru gitu ya. Mungkin ke report kali ya, analisa sama reportnya. Jelas saya Bapak Ibu ya, jelas ya. Pasti mengira itu harusnya. Bagus, agak barang soal. Ibu,
Iya, beda.
oh beda.
Iya.
Sekarang Primavera berapa harganya?
Yang sekitar
Yang
49
virtual,
yang
enterprise. Kalau yang standalone,
yang PP
profesional,
di bawah itu sekitar 6.
buat itu yang apa yang itu kan?
PP.
Apa kan?
Sampainya debat. Primavera.
Apa?
Ini.
SMA.
Oh, belum.
Sama.
Yang tadi coba.
Soalnya kan mereka sekarang memulai banyak terus. Banyak kan dari training kita tuh kirim ke itu banyak. Oh banyak sih software tuh dari ini.
Oh, bisa ya.
Bisa.
Oh, ke transfer ya.
Iya. Kita kan nggak upgrade ya.
Bukan saya.
Kita kan cuma kasih trial versionnya aja kan. Yang mereka. Lebih banyak tuh pabrik. Kita kan fokus sekarang berapa. Banyak ini ya. Bagus ya.
Proyeknya ini.
Jadi apa? Lebih ke apa? Desain lagi. Maintain atau infra. Nah, jadi mereka pakai software kita langsung kita dampingi.
Kan sistemnya bukan training, tapi kita coaching.
Oke.
Jadi coaching, jadi coachingnya langsung ke proyeknya.
Oke.
Jadi proyeknya itu kita bantu mengerjakan, misalkan gedung 10 lantai,
Oke, oke.
kita bantu 1-2, nextnya ke lantai atas. Nah kita
Oke,
lihat
base-nya itu ya.
itu
Oke, oke. Jadi dari orang kita,
dari
nggak dampingin aja.
ya bukan dari kita ngajar, kita bikin base 2
Iya, iya, iya.
mereka gitu.
Karena tipikal lo ya.
Itu
Tapi gedung aja kan gitu. Info juga langsung. Karena kita sih bayar lo berapa?
dia bisa sampai 400 bulan
Standar 3,5-400 lah ya. Untuk detail 400 ya.
ini tuh yang data center.
Oh, udah center yang mana? Kuningan. Oh, Karawang. Oke, oke. Oh,
Saya Obayasi.
banyak sih. Terus kemarin kasih training untuk company buat dagangan lagi yang di Marila Review. Tapi kita juga, itu ya,
Siapa?
anak dia tiga. Jadi Primavera. Sama sama Prima. Trainer kita tuh kemarin banyak kan. Sampai udah berapa? Dia bilang sampai udah 5. Ya kan, 3. Nggak enak kan? Nggak enak. Jadi dia beda kan? Nggak detail BIM-nya kan kalau sampai. Harusnya nih rumahnya harusnya. Masih kirim ke sini harusnya nggak jadi. Aduh. Biasanya sampai dengan sepatu bagus sih cuma itu juga. Teman lama. Ah, Bu Iren, enggak kan dari dia ada, tapi dia di beda jurusan lebih jauh. Dia di bawah. 4-5 tahun di bawah. Dia kan dari Poltek, jurusan Poltek. Pak Indra kenal, Pak Lom banyak tuh. Pak Sumran, satu angkatan dengan kami. Dulu Primavera saya ngajar juga. Satu tim untuk mereka. Masih muda-muda. Pak Edi masih ngajar? Enggak ngajar.
Ya, fokus di sini.
Banyak belajar sama Pak tuh bagus.
Oh,
Soal. Hendriko sering ngotek ya?
enggak, dulu terakhir pas waktu di Bali ya.
Di Bali ngapain?
Iya.
Oh ya.
Oh iya. Kita. Kita. Ketemu dia di sana. Di bandara.
Di sana ngerjain nih kampus Mercubuan.
Oh, dia udah barat.
Di timur.
Oh, di timur.
1,4 hektar. Barang memang saudara masih bisa. Tapi si German kan ini.
Ya.
Itu kan German bisa. Lucu juga tuh. Kita itu ya, lama juga ya, misalnya kalau misalkan ya ini lah.
Nah,
Ini yang besar itu.
sana.
Karena
Kalau
kalau
misalnya sudah pernah, dia harus cek dulu.
ya itu dia.
Itu yang
Great opportunity.
ini berurus.
Padahal kan pasti konsultasi dong.
Ada kendalanya si usernya dulu yang udah terdaftar udah nggak ada Arisa. Kalau kita order sudah ada nama perusahaan itu, kirimnya kayak yang lama. Gitu kan susah tuh. Ini saya juga nggak ada masalah ya.
Ya kan lain jadi kan. Kita kan pasti dulu dong sama bos Jeremy kan. Aman gak nih? Kita lagi gitu nih, aman nggak bisa nggak bisa. Kita calling Jeremy kan. Saya udah selesai ya kan. Ada klien gue menangin juga.
Pakai itu aja. Partner karena
Terus
inti jadi. Enough.
Ini kan masuk sel nih bro.
Kalau minta aja kan saya bisa minta itu buat dengan apa? Aku buat
Ini kita mau license nih. Jadi ada nama batu bagus ya. Namanya sakit ya.
Nah, itu bisa pinjam license. License bantuin iya. Kalau bisa punya license. Siapa kemarin itu kita udah provide. Cuma usernya nggak mau. Itu nggak mau.
Oh,
ini
Kamu boleh kita evaluation ya. Kita di provide dan
misalnya yang ya, mereka udah ada agreement sendiri dengan punya kan. Mereka kejar agreement itu ya wajar lah.
kalau misalnya sementara usulan paling lama kita kasih pinjam mbak. Dari lama.
Mau. Oh itu kemarin itu bilang ibu di sini mana bilang mau ya.
Okay.
Ya oke.
Now you have a question like that foundation, right? Or which one? Connection.
Connection.
Yeah.
The partially is what is the limit?
Okay, but first of all, out of maybe 10, so just for an example, 25% or 30% connection you will get. And secondly, a lot of things are restricted. For example, drawing generation. These things should be restricted.
There is a table to describe.
Yeah, we do have. That is also we have. Just a moment. It's already there, I think. Just one more. See, you have free versus full connection sets. Basic connection templates are available to user with the very stabilizer. These are only the very basic. They are all the smart connection and advanced connection, like smart and gusset connection. These would require the license, separate license. Yes. And there are other restriction also. Let me see it. This is free versus connection. I think this is the one. Yeah. So you can take a snapshot if you want, like the things are forward. Anyway, so that is what we have. And you can see here in the advanced tab also, random connection for design or member, these are additional license can be selected with that. So if you need some advanced capabilities, you need to have a separate license. Any question? Okay, now let me show you a quick workflow on the ISM or the iTwin. This is a iTwin, we also call the ISM. This is exactly for integration between different softwares. So all of you are in structure. Maybe you are working with your another team working on Revit, on architectural software like Open Building Designer, Tekla structures, and so on. Okay. I think you are from Tekla, right? Working on Tekla, right? You are working on Tekla structures, right? Yeah. This is the interface. This is our own interface by which you can exchange the information between STAT and other products like Tekla, Pro Structures, RAM, Stat, Rabbit, Stacks, and so on. So we have a different integration. Let me show you. This integration could be cloud-based or machine-based. Machine-based meaning your own machine, and cloud-based it could be like in your company there are different offices. You are hosting it in the cloud, and whatever changes you make, your colleague can also see those changes in a same project or common file. So let's see it. Purpose of this for model review, revision management, visualization, tracking progress, publish the deliverables, and obviously synchronizing the projects.
Can you get to before step before layer? More. Oh, okay. This integration,
Uh-huh.
integration of.
Yeah. So let's see few examples. Okay. This is the integration between STAD and iTwin Capture. It is a Revit file. Okay, you can see small little icon. We are importing it from Revit to RAM system. Anyone of you are doing tall building design, like 8-story or 12-story, small. So this is very good one. Means you can use that. STAD is very perfect, suitable for you. Means most of the things you can.
We have a comparison between stuff and stuff.
We can't compare with others. Oh, okay, so the set can compare us quite easily. We can give our own benefits, show our own differentiation. If someone asks that if this feature is, a lot of users come back to us. I get this result in SAP, ETABS, view. Why there is a difference? I can't say that SAP or ETABS is doing wrong, but I can say that what our calculation is. Just tell me where we are wrong. We can review it. We can't tell that other software is doing wrong or right. This is where we are importing it from. So this is okay. The next one is, I think, bigger one. This is same thing. This one, I think, yesterday that guy down to you. So the Revit structure is imported into Stat Pro. The big, bigger one. So this is the Stat, and you can whatever change you make in Stat, you can again take it back. This is another structure from Revit, and we can bring use the Stat interface. It's a long one, lengthy. So if anyone want to see the entire workflow, they can just click it from me. So this is CAD. Okay. So you can open all the section, material, every information from other software. And this is our own in-house, as I mentioned, ISM, by which you can have a kind of walkthrough view to see how it looks like as if you're working and see if there is any clash or any kind of overlap. So finally, you can see the complete rebar arrangement, just like your X-ray scan. Just see like how it looks like. Let me show you. This is model in STAD or ramp cycle system, and this ISM platform. If you open STAD Pro, there is a small icon you can see. You click on this, it will take you through this platform. And this is iTwin. Okay, so this is a kind of visualization. Also, we are providing like, okay, after you have designed, if there is any dense junction of reinforcement or not, if there is any kind of congestion area or not, you can just visualize it. And finally, this is for Tekla. I don't have any Tekla or Revit model because we don't have this license. You can scan this. If there is a workflow, you can just go through that. So anything else you want to know? Similar way, concrete, we also have steel structure where you can optimize. If you're into steel structure, please let me know. I can pass it on to you. You can generate the detailed drawing, everything. We have complete solution for concrete, steel, everything, even the connection design, ramp connection. So if you need any further information, don't be shy and hesitate to let me know. Oops. Yeah,
Gak ada yang mau nanya kan? Ini nggak ada yang mau nanya.
Nggak ada, mungkin nggak ada. Ya, lengkap kan jelas. Kita berdua kali ya. Untuk
What?
first
Pardon me?
skill model. How about skill models? Kemudian including what?
Pro steel?
I mean, that's all. I mean, but the next model, next station for steel construction. I mean,
Didn't get you.
we continue from now.
Oh, yeah, I will mention. I just reason I have asked like, anyone working on steel. No one is working on steel. If you want, then I can show you.
Is it? So,
Pada untuk semua Pak, jadi kita
yes. Tapi kayak so,
kalau ada yang dibahas nggak apa-apa Pak.
bukan.
Pardon me?
Udah. Mereka, jadi mereka mulai lagi. Mereka tahu juga sedikit aja kan.
Okay. Yeah. Anyway, I'm just opening the steel structure. It will take another maybe 1 hour. Okay. So anyway, we can add a steel structure just to give you some workflow. Okay. So we have a lot of things in steel. Okay. We have a lot of things in steel. So let me first show that what we can do it in steel. Let me open the steel. So the steel can be structure is very advanced in that we can have different types of steel sections, like it could be tapered, it could be I shape, it could be cold form, it could be standard, non-standard, so many things, right? Let me show you very interesting things one after another. Here you can see these are the roofing system, right? We have a ready-made template here, a structure wizard. Here we can directly define different kind of truss system. We can change this values. Maybe I can change it to something else. Maybe 4. Okay, I can have it. Similar to that, any other truss system I can develop. Maybe 10. 8. Complete truss element we can model in a single click. Okay. All you need is go to File, mark with the stat model, and you can bring it to your existing model. Now, similar to that, if you have any other type of shapes, for example, spherical shape. Wall, spherical, if I have cooling tower. Okay, so these are some ready-made template. Okay, some ready-made template which we can directly create and bring it into our model. So you didn't have to model them separately. Just if you change some dimension, these are already available in our database. You can import it. So this is, you can use it if you're into kind of different steel structure, or maybe in the concrete also. For example, this is a concrete. This is a cooling tower. You can use it for concrete. No issue. And let me show you the frame structure you have. For example, cylinder for chimney. You can create it like this. If you want to change the mesh density, you can further like 15, make it finer. 50. Okay. So everything you can do is from here. So with that, I had quickly created this model. We have those ready-made templates. Okay. Now, as you have this ready-made templates, you can quickly model it. Now that you can add a different properties of the steel sections. Okay. I have shown you different properties before, like standard, non-standard. Now, if you want to add something non-standard, we have something called section wizard. Please note that this is a very beautiful feature we have. For example, you are working on any built-up section. This is a built-up section from angle. Say I want to create another built-up section with angle back to back. I can create, I need to just define where I need to land it. Select profile, rotate, and also change the rotation angle to say 45 degree. Rotate. Your build-up section. Okay, I have just done it randomly. So once you've done the build-up section, you can import instead and assign the sections. Now, another feature we have in this one, we call it the free sketch. Okay, so in the free sketch, hold on. You can model any kind of shape, any arbitrary shape. I don't know how much you would need that, but just to let you know, any arbitrary shape, you can just do a kind of draw it by the freehand drawing. Anything, just randomly, I'm just going through. If you want to insert any pole, if I can take any smaller. Anyway, so this is a section. If you want, you can take it to stat and assign it. Go to file, export it to stat. It will be added in the stat section database, and from there you can import. For example, you have something on DXF file already. Someone has already sent it to you, for example. Now I have a sample DXF file in a different aluminum extrusion shape. This one. Okay. I can take this shape, export it as a general section, give it a name like microstation, where it is. Let me know the location, stat training microstation. Star 2. See, all the values should be checked thoroughly. Either infinity, right? Infinity. Yeah. Anyway, so we have exported it. Now what we are going to do, I will come out of this and go into StatPro. Okay. Save this data. Fine. Okay. Now here I am in stat. Okay. Now what I will do here, I will go to this one, user provided table, and want to import it from the external file where I have saved it. It here name is start2. Click save close. Now again, this one is added. Oh, I don't want to tamper this model, but just for the sake of explanation, I can do this. Maybe I can show by this one. 3. Now, if I show this section to you in a new view, this is a very slim section. Can you see this section? There's some issues in the graphics, but yeah, this section is well imported. Now, if you perform the analysis of this, you will get the section forces in this section. So I'm not going to use this, obviously, this section in this model. So that is the way, if you have any non-standard data, you can import it in StatPro through this section wizard. So that's a very powerful feature, especially for steel structure. Okay. Now let's see some of the other things that you can use it in the steel structure. There is something called specification, which you want to do if you are in the steel structure, like member truss, tension only member, or tension rod and all. These are non-linear analysis. And if you want to assign some release condition like hinge or partial moment release, you can assign this release condition. Okay, partial moment release, the value and all you can define. Anyway, support condition I've already shown you. Loading one is a little bit tricky in this case. You can see these are applied as a group load. Okay. And you can see these are the roof sheet, which is resting on the purlins. That is the reason you are supposed to use the one-way load distribution. You can't use the two-way load distribution, one-way load distribution, and you define the pressure intensity, and that's all. Same way you can use for the wind load. Wind load, we can just let you know. Wind load, we can define it instead by different features. For example, we have this wind load, which we have already calculated by the AC procedure. Let me show this one. Height versus intensity. Now, if you want to calculate by the codal process, for example, AC code, you can use it. But if you're in Indonesia, definitely we don't have this Indonesian code. You can calculate it and feed this information of intensity versus height in this table. And once these definitions are defined, you can select those definitions like this one. We have three different definitions, right? One, two, three. You can pick those definitions from here and define the direction of your choice. Say, okay. Now, if you have open structure, then you can put it like this. Open structure means, yeah, question, any question? Open structure has got something like no cladding, no wall. It will be passing through, and all the sections would experience the wind load intensity. Okay, so once we have defined the self-weight and the live load, what we can do is we can generate the automatic load combination generator. Same thing, but this time it's not ACI, it's a steel structure. So we can use the AISC code, American Institute of Steel Construction. And if you want to generate, you can see all those load combination will be generated. But please remember that if you're using tension only, rather than load combination, you should use the repeat load. Okay. So repeat load is for the nonlinear structure. And we have already defined this. See, I have already defined this in this structure. First, few load combinations. Let me show you. You can see these are the strength limit state. Okay. strength up to this 44 strength, and then for serviceability. These are the serviceability limit state. Okay. Now let's do one thing. Very nice example I have found. And now let's do the analysis first. Okay. Run the analysis. But please note that if you're in the steel structure, you might want to also use the P delta analysis, because in the steel structure, nonlinear effect could be very much significant. Instead, we do have the P delta analysis solver. Okay, let it do. Okay. Now go to this post processing. You can see here the displacement. as usual, just like this, you can see the axial forces, you can see the bending moments, everything you can do. Now, as I mentioned before, if you want to see like how to design it, okay, this is the analysis, it's fine, okay. Now you want to design it, right? So steel design can be done inside StatPro. You didn't have to go anywhere else. Just like concrete, you have the advanced concrete designer, but steel design within StatPro, you can do it. So there is something called design parameter. There you can see different design codes: ASC, castellated, ASC, LRFD, IS code, there is Indian code, Euro code, and so on. All the standard international design codes are there. Now we will check a very important thing here. Say, for example, I am using the ASC code and defining the design parameters. We can see a lot of design criteria we can just change. For example, FILD of steel, ultimate strength, and this is the yield strength. Then the different kind of clauses that has to be checked, we have mentioned. Now there is a very important parameter that we have, that is KY and KZ, that is effective length factor, okay? What is very much important. We can define it here. Now, once you define everything, I have not defined anything, or maybe I have not changed anything. What I did is I have just gone by the default values, okay? Default parameters. Now, there is something very interesting, which is called DJ1, DJ2, and DFF. Now, DJ1 and DJ2 are nothing, just a reference line with respect to which you want to check the deflection. And DFF is the maximum allowable deflection that you want. Now, in structures, you are also concerned along with the strength, um, the serviceability condition, like, okay, I can allow this much of displacement. Okay, it should not be like, okay, structure is safe, but it is deflected too much. You will have a lot of discomfort. So that is the reason deflection check can also be done along with the strength check here. Now let's see how we are designing it. Let's just someone has typed in some question in the chat box. What is this? Can you please read? Not this question. Okay. Okay. This is creating a lot of pain. Okay. Now let's see by designing an optimization. Okay, that's the most important part. Let's go by check code first. Okay. Now, before I show, you have seen this one, input editor, right? This is what I was telling you. This is a command prompt that we are using. Anything, if I want to change, I can change it from here. I needed to go to the graph. This is the most, no other software provides it. That I can guarantee you. Yeah, some software has got something at the bottom where you can see some log, like whatever you have made the changes. But entire model which can be controlled through this command prompt, no other software has got the syntax. And why it is so important, if you see some of the stat file which has got a huge number of plate elements, the size of the file will be around maybe 1 MB, not more than that. The reason being, we are carrying those information in this text format. If you want to attach it via email, even a bigger file, if for any other software file, this size are huge. You need to compress it, send it to the FTP site and all. But instead, you can send it as an attachment, very lightweight. Okay. Now, here you might have seen that I have made some changes. I could have made the changes from graphical user interface, but sometimes I feel like, okay, input editor is much more convenient way. Now, if I go to this one, commands, here you can see some design instructions are there. Check code, fix group, member takeoff, select, and all. Right now, we are not discussing all of them. Few of the important one, which is mostly used, is the check code, group, and select. And this one is also important, takeoff. Check code will simply check the reliable versus, actual versus reliable, demand versus capacity ratio. Okay, this is the check code. Second is the group command, which will try to group as per the type of section you want to lay for the entire frame. I will show you this. And select command will do the optimization. It will pick the most optimum section for you. And this steel takeoff would give you the complete bill of quantities, almost like a bill of quantities for the design section. Let's see how it works. Okay. Now, for example, I have started with the check code command. Okay. Now, if you can see some good example of optimization. Okay. Now, if I go to this output file or the post processing file, let's go to this utilization ratio table. I have only designed for this site purlins. Okay, you can see here, see my mouse cursor. Now you can see here, if I zoom this a little bit, some values are populated 0.819, 0.667, 0.719, and so on. Any idea what this point value represents? Pardon me?
Hello? Ya, 21.
Hmm? Any idea?
Kasihnya Anda temuan.
Pardon me? Ratio. Yes, this is design. So, what is this design ratio? Any idea?
Habis ini misalnya terkesan sampai ya.
Any idea? Any idea? Any idea?
Oke.
Ratio. Okay, let me show a very interesting thing. Okay. Chapter H. Can you see this? What does it mean?
Apa tuh Bang?
So, this is a interaction ratio. Okay. This term is for axial. This term is for one of the moment. This term is for another moment. It holds good for concrete as well, right? This is, I have just shown it for, this is chapter H. Okay. Chapter H is for combined forces. That is the bending and compression. Okay. What it says that if this term, if it should be less than 1, should be equal or less than 1. That means that if it is less than 1, then only your structure is safe. If it is greater than 1, then your structure is unsafe. So this is, it looks very complex, but if you see it, it's not that complex. Essentially what it says that you can see something like at the bottom, what is C? C. Top one is R. C stands for the capacity, R stands for the demand. Okay. So eventually what we are checking in this ratio is demand versus capacity. And it is not only for this one, it will be for all the other clauses. If you go to the shear, actual shear by allowable shear, actual compressive force by allowable compressive force. And this C, if I go to compressive forces, let's it says like, hold on. So fast. Where is this? Yeah. If you want the steel design, please let us know. We can have a separate class for this because this needs a lot of detailed discussion here. So let's take kind of axial forces compression. So here you can see this PN. Okay. So what we are getting actually from the design code, can anyone tell? Design for the compression, what exactly we are getting? Design compressive strength. Okay. What exactly we are getting? We are getting some capacity of in every member, right? How much it can take the load. Demand where we are getting? Demand we are getting after analysis of stat model. How much forces the member is experiencing. So that is the reason if you go to the code, you will only get to see the capacity of this. And this is the capacity. Okay. And the earlier equation that I have shown, it is for interaction, and this is only for purely compression. So stat will check each and every clauses, demand and capacity, and see that with what is the ratio. Out of all those different clauses, the maximum ratio would be reported. And this ratio is reported here. Here. So if you see that this ratio, all of them are less than one, that means safe. And you can also see the color code. This is like slightly, you can see green, is green in color. If you go down, this is 1.37, this is in red. So 1.37 means what? It's failed. So you don't know what is the reason for failure. Here, if you go, and if I go here, you can see it's failed. And it also shows the clauses. If you go here, you can see equation H11B. H11B is nothing but the interaction equation that I have mentioned you. In the interaction, it has failed. Which is the load case? This is the load case. Okay. Now let's see how to make it passed, because obviously you can't work with the failed section, right? On the other hand, 0.693, what does that mean? It is passed. But should I use this or can I also modify this? What does that 0.69 mean? 0.69 means my demand is around 70 times of my capacity. 70%, sorry, not 70 times, 70% of my capacity. My demand is 70 times of my capacity. That means still I have 30% left for optimization. Okay. So the idea is I can optimize it so that my ratio is very close to 1 but less than 1. That is my target. That would be proper utilization of my section. That is the reason it is also known as the utilization ratio table. This is known as somewhere it is known as the unity ratio table. Someone call it the utilization ratio table. So how to utilize it? So these are the heavy section. So we can manually replace them with some lighter section. On the other hand, the one that are failed, we can replace it with the heavier section. But these are all to be done manually. But is it worth doing manually for a big structure? It's a trial and error. How much time you'll do it? So best way is to use some optimization technique here. Okay. So we have some optimization technique here. Go to the utility. So go to this utility, and if you go down, you can see here as I mentioned, I have the select parameter is also there, which will optimize it. I can choose it from the graphical user interface, or I can directly define it in the input editor. This time I'm replacing the check code command with the select command. And let's see. So now you'll see something very interesting. Okay.
Kamu mau masuk kan? Kita kan di sini.
Okay. So this is the one, and now let's see. Displacement. Utilization. Now let's see. This ratio is how much now? Next batch.
Itu kan sampai Kingston.
Next batch.
Enggak.
Okay. Okay. Now you can see the ratio. How much it is? Previously it was 1.3. Now how much? 0.795. And that was 6.69, right? It has increased to 0.85. So you can see all the ratios are very close to 1, but less than 1. Now let's investigate every one of them and see all of them are passed now. If I double click on this, sorry. This is the section which is. So this is the section which was originally used. Okay. This is the section which was originally used, actually used initially. And this is the section which TAD has optimized for me. So just remember this section, 12 by 26. Okay. So this is the actual section. This is the design section, 8 by 24. Let's see this one, 8 by 24. So let's see this one, 8 by 31. This one, 8 by 24. So what do you see this? We have different section chosen by the program. Can we use that in our site, design site? Can we use different section for this Parlin? How it look like? It will look like this, right? Something like this, abrupt shape. Can we use this, the cross section shape? Okay, seeing it from the plan. If can we put this like this? It has to be uniform, right? It can't be up and down, right? So we have to make some uniform shape all across, right? But as we have done the optimization, every member was selected with a different depth. So what we need to do here? Any idea? Out of this, we need to select the most optimum one and assign it to all the other members so that the uniformity is maintained. So that is the reason we have something called group command. This is the group command. Okay, if we group it, let's see.
Pakai apa? Pakai apa? Yang lain. Pakai apa ya nanti ada video.
Okay, now let's check this guy. This is the actual section. This is the design section. 12 by 26. Just remember this, okay? 12 by 26. 12 by 26. If I go to the last one, 12 by 26. So you can see the entire optimization is done by StatPro, okay? And after you've done this, you can also generate the drafting drawing out of it. Okay, all the calculation and everything, you can see all the calculation and everything would be reported in this one output file, complete calculation, section classification and all, buckling, where it is failed, what is the clause, what are the equations, everything would be printed here. Now, if I go to the quick detailing of this steel auto drafter, and say, for example, this is another application of a steel auto drafter. Maybe something to do with Tekla also. You can just have a feel of this. This is the drawing that is generated. Okay. And these are the grid lines and everything. Legends and everything is there. Just if you want to know or change the style, you can go to this one and change the different annotation level, style, fonts, appearance, everything. You can make the changes. Okay. Height and everything. So if I want to make the change, see how it looks like from this view, you can see this is another detailing. You'll have all the grid lines and everything, and you can save it in the same DXF file, which can be opened in AutoCAD, MicroStation, and everything. And finally, connection design. Let's see, because we have done the member design, now we have to do the connection design. Okay. Just one moment. Let it open. Crashed. Okay. See, from StatPro, you have so many components or the products that are connected. Foundation, I've shown you for RAM concept, then steel connection. Steel connection is connected through the RAM connection software. Now you can create any connection from here. For example, I want to design this connection. There are different options there: basic connection, smart connection, gusseted connection. And try with the basic connection. From there, I can choose the different design codes. And I have a different type of templates, BCF, BCW, all the different connection templates. You can see a lot of different templates are there. I can pull in there. And for example, I have made one of the connections, I think this one. This is your connection. Okay. Now here you can see all the joint forces, everything were imported from StatPro. Okay. For all the load cases. And this is the design ratio. And here, not only that, you can also do a lot of changes. For example, you want to add some stiffener, you can add those stiffener, you can just play around like, okay, these stiffeners and everything we can add. And if it is not to bolted but welded, you can accordingly choose them from the different options. Say, for example, it's welded, okay? This is the welded. So let's see the bolted one. And if you want to change the number of bolts from here, you can see, and immediately you can see the ratio is also getting changed because the capacity is changed. We have increased the number of bolts, so capacity increased, so the ratio is decreased. And this is the results.
This using RCDC.
This is RAM connection, not RCDC. Yeah, RCDC is for concrete. This is the calculation. If you want the detailed calculation, it will show complete list of calculation with the formula involved. So this is where you are. And if you want to see the DXF file, you can see the DXF file here. And this is the connection detailing, okay? And same thing you can again export in the DXF file with the scales and everything. Wherever you want to save the file, you just give the file name and all those connection notifications.
Can you show the print preview for the report?
Print preview for a report. For which one? This one?
Yeah,
This one, okay. I've shown it.
That's also.
No.
It's the RAM.
This is RAM connection, yeah.
Okay.
Okay, print preview, okay. Let me show. Let me close it. Let me close it. This crashed. Maybe this department. So many models open. No, it's okay. Let's go into file name, new. Now let's go to result and take the print. Let's see. If this is in the Word file, okay. This is already in the Word file. Export it to report, for example. Say I'm just saving it in anywhere, maybe here. So if I open it in Word, I can find this report. So this is your. You can get more detailed report if you click on the formula. It will give you more detailed report. Also, you can insert the picture of the detailing and everything in this report. Yes, everything. This is a concise one. You can get the detailed report. Let me show the detailed one. Hold on. This is, for example, I want
Caranya macam ya, dia pulang kuliah nih.
Iya, Pak.
Tingkat berapa?
Enggak tidak.
Tingkat 3. Udah belajar software engineering ya, satu tes ya.
Iya, Pak.
Okay, so again, you can save it. It is the report. You can open it in the Word file. You can see the detailed report. Okay, any question? Anyone?
Kayaknya ada mau yang aja terkait apa di kampus terkait soal apa implementasi software. Apa? Bisa nggak, bisa ini nggak, selama ini pakai SAP Pro bisa apa? Belum ada Pak Biswas. Selama ini ngerjain apa kan, ngerjain pekerjaan mekanika atau desain, bisa nggak SAP Pro begini? Kita selama ini kan udah berjalan waktu ya, jadi nggak ada apa yang dosen aja ya, itu lumayan. Aja. Ini yang selesai. Indonesia boleh itu. Ayo mahasiswa harus berani, mahasiswa. Ayo, kamu malu-malu ya. Tanyakan aja. Selama pekerjaan kampus belajar. Ayo, nggak semua malu. Indonesia aja sampai atau Inggris langsung boleh. Indonesia dulu nanti ada di sini ya.
Pardon me?
Yeah, I let them to ask about
Question?
the question about structure visa.
Yeah, anything you can ask. Don't hesitate. Don't be shy. In your language, you can ask. She can interpret.
Iya. Ayo, siapa nih? Bepasa, ayo. Rapi, ayo. Siapa nih? Mbak siapa nih? Mbak Nani sih? Ya, bukan. Mbak siapa? Mbak Tia ya? Nah, terus apa lagi? Mbak siapa nih?
Ilza.
Hah? Ilza, Mbak siapa? Ayo, tanya, ayo. Ayo, nanti saya malu ke dosen itu. Kalau enggak. Nih, ya, coba nanya apa aja. Ayo.
Can you please let me know what kind of structure you are right now handling in onshore, right? Like how you are designing it in Excel or any other software. Can you interpret?
Gimana, Bu? Pakai start ya?
Iya.
Tapi sampai sini nggak desain?
Masih
Oh, mana masih data spreadsheet lagi. Itu tuh ditekankan tuh. Ya kan?
connection dulu.
Tapi report tuh sudah menggunakan report tapi ini kan masih pakai spreadsheet.
Ya.
Coba pakai ini ya. Coba.
They're doing like the shop project. Already used the report feature from start, but for connection they haven't tried it.
Still connection?
Yeah, they haven't tried it.
Yeah, then try it. Who is stopping that? Try it. RAM connection is a very powerful feature. Not only that, you also have the base plate. Let me show you. Might be I have this one. Select any connection for the base plate. You can also, for shelter one, you need to also do the base plate connection. Could be of different types, normal, J-hook. Let me see, this is added J-bolt. I'll show you this one. This is the detailing and all. So many types of connection means just two of them I have shown you. So many types of connections. If you have the bracing like this, you have those connections, the bracing, everything. And also one thing, this is optimization. It will also optimize. the thickness of the plate or thickness of the welding, how much you need, it will tell you. Yes. Anyone from you? Anything from you? You need more information because you are working with Tekla.
Yeah, do you have some sample for profile pipe profile?
Mhm.
So using the pipe profile.
Pipe profile.
Yeah.
Pipe, we already have it in the standard database. Hold on. Legacy. Okay, you can, first of all, you can create those pipe directly from here. This one, just define round and shape. Second is if you want to use it from standard database or profile table, you can also do it. Let me open it. It's taking too much of time. This is pipe. Okay. You have all those things. If you still want to add, if say for example it is not available here, either you can add it to this prismatic that one I have mentioned, or else you can go to this section database like this. There is you have this legacy, gold, steel. Here you have some pipe. You'll get the entire table. Okay. Now in this table you can add your own profile. Just you need to unlock this. For example, you need to. This is the unlock button. If you unlock, you can add the row below or above. You type your own information, give the pipe, outer diameter, inner diameter, thickness, everything, and save it. It will be saved in your database.
How about the connection?
Connection.
I want to know.
Pipe connection. Oh, pipe connection. Okay. For pipe connection, I need to open a model that has
Automatic or must define.
Oh, okay, let me open this. Let me see if I have anything on pipe. I had a similar model, just one moment. See if I have it. Hold on. My cursor is quickly working. Let me close few models. So many models I have. I can't see my cursor here. What happened? Okay, let me model, let's say, steel connection, steel design here. Maybe got the name of this. Just a Okay, let's create one. Let's see. Okay, now let's specify. Maybe depth is 0.5, thickness 0.01. Assign to view. Okay. Here we have something like, let me see the shape first.
Almost the same, you get stuck on.
Huh?
So input line,
Yeah, yeah.
almost same with stuck on.
You can change a lot of things here. This is a very simple model I have chosen. Now, number of poles may be 16. Well size may be 5-inch. Thickness and everything, I can make the changes. So this is my design model. Yeah, yeah. You can change a lot of other things from here if you need to change the thickness, welding thickness, type of material in the welding, electrode, everything you can make the changes. Okay.
If you want to bring this draw,
Drawing
draw, it's for 3D.
3-dimensional. This one only you need to take the snapshot of this. 3-dimensional, this one can't. This you take this 3-dimensional. I think it's I have to restart the machine after this. So much of data. Means every time someone is asking me opening the file means so much of means the data consumed. Yeah, I have to show this. I'm supposed to. Uh, yeah, this you can save this image, okay, and save it somewhere in, for example, in a desktop. For example, I want to save it in the desktop, maybe flange, pipe flange. Yeah. My cursor. Don't know why my cursor is not being shown here. It's very difficult to. You can take this printout. You can save this one, and for the 3D, all you need to do. I think this is creating this problem. This zoom. Once you save this to your desktop and everything, you need to take this image and put it in your Word file. And this is another one, you can directly export it into the DXF. Okay. Any question you have? Any question?
Ada? Satu nanya deh. Satu
Online,
nanya.
those who are online, any question?
Online silakan. Ada yang bertanya silakan. Ayo, satu orang dari Tama. Mana nih? Ya enggak. 1, 2, 3. Ya udah. Ya udah. Ayo. Ayo, banyak.
Itu tadi kan kita kayak salah nanya kita. Itu berarti dari itu visual. She's asking if we use from protection. Does around extract the internal forces from stand model. Yeah. So dari start.
Cursor, I don't know what's my. See my cursor.
Ya, ya.
Whatever. Stop.
Namanya kalau pakai program ini untuk dia untuk gempa Pak iya kalau misalkan bisa melakukannya gimana oke thank you terima kasih
What?
okay can start perform dynamic analysis
Yes.
if yes how to perform that
Okay. I'll perform the thing.
Yeah.
So it's a long chapter. Are you there in the second half?
Simple answer.
Uh-huh.
Simple.
Oh, okay. The simple answer is yes. If you want how, then obviously it's not a simple. So obviously at least it need 15 to 20 minutes maybe. Because dynamic analysis is nothing to consider as a simple thing. Restart my machine. Any question? Okay, if you ask the question, let me show you. Dynamic analysis, definitely. Why not? Oh God, again, it is. I think this is the reason. Cursor is getting vanished. difficult to open. Okay, I'll show you a very interesting dynamic example. Okay, it's not like a regular one, something very interesting. Oh my god, this cursor is how to see this series. I want to search it, but I can't see my cursor. Sometimes it appearing, sometimes video. Okay, just be online and what you will do with the dynamic analysis. Can you please let me know? I'll just let you know some background. What is the purpose? What will you do with dynamic analysis? Where you will apply it?
Kenapa? Maksudnya bahkan hanya faktor ya. Memang hanya itu tuh karena mau dikerja pakai di tugas sama gimana gitu. Kita nanti kalau di mata kuliah desain lomba ya, jadi ya itu menurut aplikasi ini. So they are the university student.
Okay.
And
Oh,
then she want to take this lecture for the earthquake.
Okay, great. There's a reason. Please allow us some time so that I can explain you in detail. Definitely, we will discuss it. Let me show you one of the example of dynamic analysis. After that, I will restart my machine so that it will run faster a little bit. Yeah, I'm done. Dynamic analysis, right? So let's do one thing. Let's what is this? Time step. Great. Let's do the copy. Yeah, here I will show you. I got it. I think this cursor issue should be solved, or else I had to restart my machine terribly. Last, okay. Can you see this?
Sorry.
What happened here? Can you? There's a blast, and the blast wave is hitting, and we are simulating at different time step. Unfortunately, I don't have the cursor to move it around. Maybe after I restart in the second half, we can discuss. They will be there in the second half? Oh, they won't be there. Oh, last part. So why didn't you come in the very beginning? We could have.
continue.
Di saya nanya kenapa baru join
Karena di luar dari
What?
harusnya kemarin tidak datang dari mereka mau sepakat kan hari ini once.
Can you please let me know?
question comes.
Lanjut.
What?